Hi, I'm Matt Ambrose with the Defense Acquisition University, and I'd like to take a few minutes to talk about the 4 basic cost estimating techniques that we use in defense acquisition to get cost estimates throughout the life cycle of a program. So the first one is analogy. It's one of the ones that we tend to use early on. It's fairly easy to understand. We subjectively compare a new system to data that we have on an old system. So just for instance, we have data on the F-18. Right, we want to come up with a new attack aircraft for the Navy. So we're going to use that to give us some basic cost estimates for what it might take to develop the next attack aircraft for the Navy. So that's fairly easy to understand. Some of the strengths, it's quick. We've got the data on hand. We can use that data to get a fairly quick cost estimate for the new aircraft. It's also usually inexpensive and fairly easy to change. Anytime we change our assumptions, we can change the assumption in the analogy and get a new cost estimate. It is subjective, so that's a weakness of this particular method, and it tends to be not as precise as some of the other methods that we're going to look at later, but it is a good method early on for getting a good ballpark of what our system is going to cost to develop and procure later on. So let's look at another one. The parametric method is also usually used early on in the life cycle. It uses statistics. So we've got to have a statistical database out there of information that tells us that there is some relationship between the cost of a system and some characteristic of that system. So the way that kind of works is, let's just say we're talking about submarines, and we've got lots of data on developing submarines and building submarines that says that the cost of the submarine varies based on the volume of the submarine. So we would put a model together based on the data that we have, and we would plot out a relationship between cost and volume of the relationship of the submarine, So that would plot out as some kind of a curve, probably. And then we would, as we get the design in and we see what the volume is going to be, or we estimate what the volume is going to be, according to the design, we would take that up, and then that would give us our cost for a submarine with that volume. So that's kind of how the parametric method works. Some of the strengths of this parametric method are that it does use good solid cost estimating relationships, right? It has data, we have data to prove that this has in the past been true. So it should be true in the future, or at least close to true. It's fairly easy to do what-if drills, right? If your design changes, volume changes, you can change that in your model and you can get a new cost estimate, fairly easily. And it's usually fairly inexpensive because, again, like the analogy method, we have the data in front of us, so we don't have to go out and build a whole lot of anything other than maybe the estimating model that we're using. Some of the weaknesses, it is still a bit subjective, and it's only as good as the data that we have, right? We can only be as confident in this estimate as we are confident in the cost estimating relationship that our data from previous systems actually tells us exists. So let's look at maybe a more precise method here, the engineering or bottom-up method of cost analysis. This is where we take every piece part of our work breakdown structure here, and we look at what is it going to cost to do that work and to build that piece down to every nut and bolt on the system. So that's fairly easy to understand as well, but it does have its own strengths and weaknesses. It's very accurate usually because you're looking at what is it actually going to cost for each thing that I'm going to do and build on the system, and that limits the subjectivity of it. Some weaknesses is it's very expensive. You can imagine the amount of time it takes to put an estimate like this together when you're looking at estimating every part of the system and every test that's going to happen, et cetera, on the system. So that makes it very time consuming. And it's also difficult to do those what-if drills. If we have a model or we have an analogous relationship, that's pretty easy to change if the design changes. But in this case, the design changes, you've just changed parts. You've changed things that have to be done. You've changed the test plan. So all of that has to be redone. So again, it's very time consuming, and it's not very flexible in terms of looking and doing what-if drills on your system. Now, the last one that we want to talk about here is probably the easiest to understand, and that's actual cost. So we have built something already. We know what that costs. We should have captured those costs from the contractor on what it cost to do that. We built hundreds of Liberty ships during World War II. So by the end of World War II, we knew what a Liberty ship was going to cost. Same thing with a weapon system. So M1 tanks, if there's still a hot M1 tank line, we can take and say, what did it cost to build that last M1? That's probably very close to what it's going to cost to build the next one as well. So we use actual cost to extrapolate from. Strengths of this one, there's very little subjectivity in it. Hey, we've got real data here. It's very accurate, fairly inexpensive. The weaknesses here is it doesn't apply for most of our weapon system development. It only applies once we actually start building systems. Once we start building systems, then we actually have costs for what those have been costing the government to that point. Also, because of the way our system works in terms of budgeting and planning and programming, it takes a while to get dollars. So it may not even be applicable in terms of putting in your money when you need it, especially for initial procurement. So it does have some weaknesses, but it works great once we get into production, because now we have real production costs that we can use to estimate future production costs. Okay, so I have talked a little bit about where each of these cost estimating techniques really works best within the life cycle. So let's just kind of plot that out. So for our analogy method, that works great early on. It's a good way to get your initial cost estimates done and then to update those as you go. Parametric is similar, typically used about the same time period, maybe a little bit further along through the cycle. Again, good early technique when all we really have is historical information here. The engineering method is good pretty much from the time you start designing throughout the rest of the life cycle, then, because you can use the design then to get a cost estimate for how much it costs, because that's that bottom up piece part estimate. And then lastly, once you start into production, you can look at the actual costs of what you're getting, and that can provide you with good information, good accurate information on what the further production down the line is going to cost you. Okay, so this has been just a quick overview of the 4 basic cost estimating techniques that we use in the Department of Defense to estimate the cost of our acquisition programs. I hope it's been helpful to you. I hope you take advantage of the cost estimating courses that we have both online and in the classroom. Thanks for watching.